We're going to build on what we learned yesterday by talking about how place value can play a role in whole number operations, like adding, subtracting, multiplying, dividing. Now, most of us learn to add using what's called a traditional algorithm. We set up a problem like this, and then we add each place value. So I would add the ones place first, 3 plus 5, 8. And then I would add the tens place, 1 plus 2 gives me 3. But this isn't just 3, it's 3 tens because it's in the tens place. So this 3 actually represents 30. And this whole number is 38. And we use the same kind of algorithm for subtraction. 4 minus 2 is 2, 5 minus 1 is 4. And we get 42. When we follow a certain set of rules for following a math problem, it's called an algorithm. The one we just looked at is called the traditional algorithm because it's the most common form. If I had this problem and I set it up using the traditional algorithm, this is how it would look. However, there's another form that I can use. It's called expanded form. And if I use expanded form, I take this original problem, 551 plus 138, and I expand it out based on its place values. It's the same problem, 551 plus 138, just broken down into place values. I still solve it very similarly. I go place value by place value. So 1 plus 8 is 9. 50 plus 30 gives me 80. And 500 plus 100 gives me 600. Now I combine 680 and 9 into just our answer, 689. We can also use expanded form when multiplying. So instead of setting up our problem using the traditional algorithm, 162 times 5, we can break it down into place value. 160 and 2 times 5. Solving it this way helps break down what I'm actually doing with each of the place values. Here, I might think that I'm multiplying 5 times 2, 5 times 6, and 5 times 1, but what I'm actually doing is I'm multiplying 5 times 2, 5 times 60, and 5 times 100. I'm going to solve it this way first and then use expanded form to prove that we get the same answer. So 5 times 2 gives me 10. I write my 0 here and I carry my 1. This is traditional algorithm. 5 times 6 is 30 plus 1 gives me 31. I drop down the 1 and carry the 3. And 5 times 1 is 5 plus 3, and I get an answer of 810. Now I'm going to solve it using expanded form. 5 times 2, that's 10. 5 times 60 is 300. And 5 times 100 is 500. Now I just add the values in my answer to get the final answer. So 500 plus 300, that's 800, plus 10 more gives me 810. And what do you know? That was our answer from the original problem. So we're going to build on the graphing part of yesterday's lesson as well by talking about a different way to create a bar graph. Yesterday we looked at a vertical bar graph where the bars went vertical or up and down. Today we're going to talk about a horizontal bar graph. The reason we might use a horizontal bar graph is because it better represents the information being displayed. So in this example, we're talking about the distance that somebody ran. Because we're talking about distance, it makes sense that we might have a bar that shows us distance over a graph. So one thing I want you to notice is at the top here, I have a title for my bar graph. It says distance race. That kind of lets us know what this entire graph is about. The other thing I have on here are labels for each of my axes. This label says runner, and I have A, B, and C, so there's 3 different runners here, runner A, runner B, and runner C. And this axis tells me the distance that they traveled because I have this label here that says distance, and we also know that we're talking about miles as opposed to feet or inches. Last thing I want to mention is the scale that we have on this graph. Our scale shows us the value as we go up along this axis. So just to quickly analyze what this graph is showing us, we can see that runner A ran nearly 15 miles. Runner B ran close to 3 miles, and runner C ran about 9 miles.